question 5, we have g of x is equal to x squared minus 1 over x. Find g prime x, derivative of g of x. Let's write g of x down in simpler terms. It's equal to x squared minus x to the minus 1. And then g prime x, we're differentiating. So we're going to get 2x, bring the pair in front, multiply by the number there, so there's a 1 here, so that's minus 1 by 1, so it's plus 1x to the minus 2, which is going to be 2x plus 1 over x squared for part 1. When you looked at part B, you thought to yourself, do we really just have a box method question? What did I tell you was coming up? Box method question. I didn't predict the remainder at the beginning, but it's the same question. 2x cubed. If you weren't doing a merry dance at this point, you should have been. X plus 1. You should be doing these in your sleep at this point. 2x squared on top. 2x squared on the bottom. Couldn't be easier with the 1. How many x squareds do we want? Minus 21. So we want minus 3x squared. You are going to be having nightmares about me saying these box method questions for the next 50 years. So then we say x into minus 23x squared is minus 23x. Then we get minus 23x on the bottom. How many x's do we want? Plus 40. You might be panicking at this thing, it might not work, but we need 63x here, you can see, to get 40, which would leave plus 63 on top. And does plus 63 by plus 1 equal plus 63? It does, so we know we're correct. No remainder. 2x squared minus 23x plus 63 is our quadratic. We're asked to find 3 values of x for which f of x is equal to 0, so the roots, so be careful. This one, x is equal to minus 1. Let's get the other 2 roots. Does it factorize? It has to factorize, doesn't it, for us? Make it the shortest question in the history of higher level maths. 2x by x. 7 by 9 is 63. That's normally the one that works with 63. Does 7 and 9 work? So 14 and 9 is 23. Both minuses. So x is equal to 9 over 2. 7 or minus 1. So in under 3 minutes, the whole question. Let's see the 7 work. I think it does work nicely here. If we put 7 in, let's just have a bit of fun. Gives you time at the end of the exam. Does 7 work? 2 by 7 cubed minus 21 by 7 squared plus 40 by 7 plus 63. This is going to give 2 by 7 cubed. I'm going to keep them as cubes here. This is 21 is going to be 3 by 7 is 21 by 7 squared. So that's going to be 3 by 7 cubed. So we have 2 by 7 cubed at the beginning, minus 3 by 7 cubed. And then we have plus 40 times 7. We also have plus 63, which is 9 times 7. So this will work out to be 40 and 9 times 7, which is 49 times 7, which is 7 squared by 7, which is 7 cubed. So we have 2 by 7 cubed minus 3 by 7 cubed plus 7 cubed, which is 3 by 7 cubed minus 3 by 7 cubed, for no other reason, to just show that this is equal to 0. So when I'm getting distracted, the last part, the range of values for which f prime x is negative. So your instant thinking here is the range of values where the quadratic will be negative will be in here. So let's have a look. We have f of x, f prime x is equal to 6x squared minus 42x plus 40. Where will we find the roots? Let it equal 0. we can divide by 2 to get 3x squared minus 21x plus 20 equals 0. And before I go to start factorizing, 2dp, so quadratic formula. Stick it into your calculator, check it twice. What am I getting? I'm getting 5.8629 and 1.137, and then rounding to 2, I'm going to get 5.86 and 1.14. So they're both positive, not like my sketch. So it's over here. Where does it cross the y-axis? At 20, say for our one. Doesn't really matter, but we're looking for the range of values. They're in here. 5.86, 1.14. So we have x is going to be between 5.86 and 1.14 for the actual last part of this question. Still a nice short question in 2022.